In 1972, French scientists examining uranium ore from Gabon made a discovery that should have been impossible. Deep within ancient rock formations, they found evidence of nuclear fission that had occurred 1.7 billion years ago, long before any known natural process could have created it. The isotope signatures were unmistakable. Depleted uranium-235, fission products arranged in patterns that mirrored modern reactor waste. Nature, they concluded, had somehow built its own nuclear reactor. But what if nature had help? Picture this. Synthetic polymers discovered in sediment layers dating back 56 million years ago. Carbon isotope spikes that mirror industrial emissions, but from an age when mammals were just beginning to dominate the Earth. Temperature anomalies in ice cores that suggest climate manipulation on a planetary scale, occurring with a precision that defies natural explanation. These aren't scenes from science fiction. These are real anomalies hiding in our planet's geological record, waiting for someone brave enough to ask the unthinkable question: if we are not the first. Two scientists dared to ask this question formally in 2018. Gavin Schmidt and Adam Frank proposed what they called the Silurian hypothesis, not because they believed in ancient reptilian civilizations, but because they recognized a blind spot in our scientific arrogance. We assume we're Earth's first technological species because we see no cities, no monuments, no machines. But what would actually remain of New York or Tokyo after 10 million years? After 100 million? The answer is more disturbing than you might think. Almost nothing. Consider the odds. Complex life has existed on land for 400 million years. Our industrial civilization has lasted barely 300. That's 0.00007% of available time. In the vast library of Earth's history, we occupy less than a single letter on a single page. How many entire books might we have missed? The fossil record whispers of possibilities we've been trained to ignore. Less than 1% of all species that ever lived left fossils. Of those, we've discovered perhaps a fraction. The Signer-Lipps effect tells us that species seem to vanish from the fossil record long before they actually went extinct. What if some of them didn't just vanish? What if they evolved, developed, and transcended in ways that left no bones behind? Strange patterns emerge when you look closely enough. The Paleocene-Eocene thermal maximum, 56 million years ago, shows a carbon isotope excursion that mirrors industrial activity, a massive spike in light carbon that heated the planet by 7 degrees in what seems like a geological instant. Scientists attribute it to volcanic activity, but the speed troubles them. It happened too fast, released too precisely the mixture of isotopes we'd expect from burning fossil fuels. Then there's the timing of certain evolutionary leaps. The Cambrian explosion didn't just produce new species, it produced entirely new body plans, new ways of being alive, as if nature suddenly discovered a library of blueprints it had been searching for. Some organisms appeared with no clear ancestors, their complexity seemingly engineered rather than evolved. We explain it through punctuated equilibrium. But what if evolution had help? What if genetic templates were scattered like seeds waiting for the right conditions to bloom? Deep beneath Antarctic ice, satellite imagery reveals geometric patterns too perfect for nature, grids and angles that speak of intention rather than chance. Ground-penetrating radar detects vast structures, cities worth of anomalies frozen in place. Officially, they're subglacial lakes and natural formations. But Antarctica has been frozen for 15 million years. What might lie beneath, preserved in Earth's ultimate time capsule? The ocean depths hold their own secrets. In sediment cores pulled from abyssal trenches, researchers occasionally find what shouldn't exist. Synthetic compounds that predate human chemistry, metal concentrations arranged in patterns that suggest refinement rather than natural deposition. We catalog these anomalies and move on, because the alternative is too vast to contemplate. But let's contemplate it. Imagine a civilization that learned what we're only beginning to understand, that leaving less trace might mean lasting longer. They would have discovered what we're discovering, that burning fossil fuels is a self-limiting trap, that covering the planet in concrete and steel is writing a suicide note in stone. A truly advanced civilization might choose technologies that decay, cities that dissolve, energy sources that leave no fingerprint. They might build with engineered organisms instead of steel, structures that live and die without fossilizing. They might harness geothermal energy, tap into planetary magnetic fields, manipulate weather systems with butterfly effects rather than brute force. Their computers might be biological, their data stored in synthetic DNA designed to degrade after serving its purpose. The more advanced they became, the less evidence they'd leave behind. Consider the nuclear signatures we've found in ancient rocks. The Oklo reactors in Gabon operated for hundreds of thousands of years, self-regulating with an elegance that human engineers struggle to match. We've explained them as natural phenomena, uranium concentrations that happen to achieve criticality. But the precision troubles some researchers. The reactor zones are too perfect, the control mechanisms too sophisticated. What if they're not natural reactors, but the buried remains of something designed to look natural? Mass extinctions punctuate Earth's history like chapter endings, each one clearing the stage for new actors. The Permian-Triassic extinction erased 90% of marine species in what looks like a geological heartbeat. The patterns are telling, not random death, but selective pressure, as if someone were culling specific branches of life's tree. We blame volcanism, asteroid impacts, climate change. But what if some extinctions were managed? What if Earth's biosphere has been gardened by hands we can't imagine? The chemistry of extinction events holds clues we're only beginning to read. Mercury spikes that speak of massive industrial activity. Sulfur isotopes arranged in ratios that nature struggles to produce. Layer after layer of black shale, the graveyard mud of dead oceans, containing trace elements that whisper of artificial origin. Each extinction reset the evolutionary clock, provided fresh clay for new experiments in consciousness. Perhaps they discovered what we're approaching, that consciousness needn't be confined to biological neurons. In Earth's magnetic field, in the quantum entanglement of mineral crystals, in the vast mycelial networks that connect forests, they might have found ways to encode memory and experience. The planet itself might be a library, holding archives we lack the technology to read. Some researchers studying evolutionary convergence note that intelligence seems almost inevitable given enough time. Eyes evolved independently over 40 times. Flight emerged in insects, pterosaurs, birds, and bats. But technological intelligence appeared only once, or so we assume. What if it's appeared repeatedly? Each iteration learning from the last, each one encoding lessons in the only medium that survives geological time, DNA itself. The octopus troubles our assumptions. Its distributed intelligence, alien neurology, and RNA editing capabilities seem too advanced for its evolutionary timeline. Some geneticists joke that octopuses are aliens. But what if they're not aliens, but inheritors? Biological machines designed by predecessors who knew their civilization would end, but their experiments might continue. We find microplastics everywhere now, a signature of our age that will persist for millions of years. But in ancient sediments, researchers occasionally detect similar signatures, synthetic polymers that shouldn't exist, complex hydrocarbons with no natural origin. We dismiss them as contamination, but the patterns persist across multiple sites, multiple studies. What if earlier civilizations also struggled with their waste, also marked their presence with imperishable mistakes? The moon might hold answers Earth has erased. Its surface, unchanged for billions of years, could preserve artifacts that would have vanished on our dynamic planet. Some researchers have proposed searching for ancient mining operations, launch sites, or debris fields. The lunar samples we've collected hint at anomalies, unusual metal deposits, glass spheres that could be natural or could be something else. We've barely scratched that ancient surface. Time might be cyclical rather than linear for intelligence on Earth. Each civilization rises, peaks, and vanishes, but not without effect. They might leave genetic breadcrumbs, bacterial libraries, mineral signatures designed to nudge the next iteration toward faster development. We could be living in a prepared world, a planet pre-configured for technological emergence by those who came before. The Silurian hypothesis forces us to confront our cosmic loneliness differently. Perhaps we're not alone because we're the first, but because we're the latest in a long line of experiments. Each civilization might face the same bottleneck, the moment when their power exceeds their wisdom, when they must choose between transcendence and extinction. Some might have chosen transcendence, uploading their consciousness into quantum substrates we can't detect, retreating to dimensions we can't access. Others might have chosen transformation, engineering their descendants to survive in forms we wouldn't recognize as technological. The octopuses with their RNA editing, the dolphins with their name signatures. What if these aren't just evolved organisms, but designed inheritors of ancient knowledge? As we pump carbon into the atmosphere and plastics into the oceans, as we split atoms and edit genes, we're writing our own geological signature. Future scientists, human or otherwise, will read our layer clearly, the Anthropocene, marked by radioisotopes, mass extinction, and chemical creativity. But will they also wonder what we wonder? Will they ask whether we were the first or merely the most recent? The implications shake the foundations of human uniqueness. If civilizations rise and fall like seasons on a geological calendar, then our current crisis isn't unique, but universal. Every technological species might face this moment, when they must evolve beyond their biological origins or join their predecessors in the fossil record. The climate crisis, the nuclear threat, the biological revolution. These might not be unique challenges, but standard tests, filters that every potential galactic civilization must pass. Perhaps that's why the universe seems so quiet. Not because life is rare, but because transcendence is hard. Each world might host sequential civilizations, each one learning slightly more, encoding slightly deeper lessons in the planetary genome. Earth itself might be a school, and we're currently failing the final exam. But we have advantages our hypothetical predecessors lacked. We can imagine them, learn from their theoretical mistakes. If they existed, their greatest gift to us might be their absence, the missing fossils and impossible isotopes. They're telling us what we're beginning to understand, that true advancement means living within planetary boundaries, that the highest technology might be indistinguishable from nature itself. As you lie awake tonight, consider this. Earth forgets, mountains erode, oceans recycle, continents drift and collide. In 1,000,000 years, humanity's greatest achievements will be compressed into a thin layer of unusual sediment. But if we're wise, if we learn the lesson written in deep time, we might break the cycle. We might become the first Earth civilization to leave more than a geological scar. Or perhaps we'll add our own isotope signature to the growing list, another data point for the next species to puzzle over. They'll drill their cores, analyze their samples, and wonder, as we wonder now, whether they're alone in deep time, or whether intelligence on Earth is less like a unique event and more like a tide, rising, falling, that always returning, each wave reaching slightly higher up the shore. The question isn't whether ancient civilizations existed. The question is whether we'll become one ourselves, a mystery for future minds to ponder, or whether we'll finally break the pattern and endure. The rocks remember what we've forgotten. The earth waits to see what we'll choose. Listen to the stones. They're trying to tell us something.